Welcome everybody, lesson 2.7 on piecewise functions. Here's your title, make sure you get it in your notes, 2-7 piecewise functions. Our goals for this section are to represent piecewise functions with graphs and to use these functions to model some real life situations. We're going to begin with Bert. Here's an intro problem about Bert. Bert decided to take a bath with his rubber ducky. When he begins to fill the tub, he turns both the hot and cold handles on all the way and fills it at a rate of 4 gallons per minute. After 5 minutes, he turns off the cold water and fills the tub at a rate of 2 gallons per minute for 5 more minutes. Now the tub is full enough and just the right temperature. Bert soaks in the tub for 15 minutes. After he's squeaky clean, Bert drains the tub empty at a rate of 5 gallons per minute. Create a graph of this situation comparing the gallons in the tub, the y-axis, to the elapsed time on the x-axis, and identify all those important points talked about in the paragraph here. Please pause the video, do your best to try and create a little graph. Alright, how did you do? Here is the answer that I came up with, done nice and easy for you. This blue line here at the beginning, this represents, going back to the paragraph, him turning on both hot and cold water and putting in 4 gallons per minute. Now after that 5 minutes, he turns off the cold, so it's kind of moving, the water's filling the tub slower. So notice how this is going a little slower here. This one fills it up pretty fast, and this one fills it up a little slower. After this 10-minute period, he turns off the water, so there's no more water coming into the tub. And then back to the paragraph here, then he's going to empty that tub. He empties it at 5 gallons per minute, kind of like the same rate, almost the same rate as when he first started. So going and looking here, then the water drains out till empty. Now, you didn't have to have this graph exactly like this, but it should be pretty close. This is a real-life example of a piecewise function because there happens to be 1, 2, 3, 4 different pieces. In this case, there are 4 different lines. Piecewise functions doesn't have to always be lines, but as of right now, that's really the only thing we're studying, so our current piecewise graphs will always look linear for now, couple lines. Here's what they look like in terms of function notation, so I'm going to highlight a few things here for you. So taking a look at this, you're going to have a f of x, which is y, and then it's going to equal a curly bracket, and you're going to have either 1 or 2, maybe 3, 4, 5 functions. So let's start off easier with these 2. There's always going to be these little conditionals here, the if statements. That is not the inequality from lesson 2.6. This is just telling you when to use this graph. Only for x values smaller than or equal to 3, less than or equal to. So looking at this first one, you're supposed to evaluate, get an answer, when x is 0. Which one do I use? Well, hey, 0 is less than 3. Use the first one. So here is the answer and the solution to A. F of x, which now changes to 0 because I'm substituting in 0 for the x is 0, and I put a 0 in there also. So I'm only using that top function currently. 3 times 0 plus 2. 3 times 0 is 0, 0 plus 2 is 2, the answer is 2. That's basically how you do evaluating a function, a piecewise function. Why don't you attempt to do x equals 3 and x equals 6, pause the video, and I will show you the answers in a moment. B. Well, since 3 is less than or equal to the 3, I still use the first function. So putting in 3, I get 3 times 3 plus 2, 9 plus 2, 10, 11. It's 11. Pretty simple. And part C, this is now the time we jump to the bottom function due to 6 being bigger than 3. Only use this part. So substitute in 6. F of 6 equals 6 minus 1, x minus 1, x is 6, answer 5. This is how to evaluate a piecewise function. Now moving on, how do you graph them? Well, notice here's another piecewise function with 2 different lines. How do I know they're lines? Because they're in y equals mx plus b format. Don't have to be, but in this case they are. I'm going to start with this special little conditional here again, and this is the spot on the graph you switch functions. Here is 2 on the x-axis. Mental note, 2. Now I'm going to graph this one. Ooh, this is tricky. The y-intercept is 2/3. Here's 1, 2/3 is about here. 2/3 of the way to 1. And then I do rise over run, up 2 over 3. Now let me change colors here to show you how I'm going up and over. Up 2, 1, 2, from 2/3 to 1 and 2/3 to 2 and 2/3, and then jumping over 2 spots. That's the rise 2. Oop, I'm sorry, I should have ran 3, so I have to go 3. Now, if I just draw this regular line like this, that's the entire line, 2/3 x plus 2/3. However, I only want it when x is bigger than 2. Here's that magic 2 zone. So I'm going to get out my eraser, and I'm not going to graph this part of it. Ooh, I wanted all of it, but not that part. So starting here, okay, it kind of started here, and it drew, but when do I start drawing it? As soon as I get to the magic value of 2. That kind of runs along the x-axis here. Not on the x-axis. All of these are 2's. Now, another thing is, this is not an equal to symbol like this one is. So I need an open circle here to delineate between equal to and not equal to. This will continue to run to the right because that's x is bigger than 2. If you want to give this one a try, give it a try. Pause the video, and I'll show you the answer in a moment. Y-intercept is 1. The slope is -1, so down 1 over 1, down 1 over 1. Here is my line. Now I'm going to draw it to the left of 2, because to the left of 2 is less than or equal to. Goes on forever in that direction, closed circle on the end due to the equal to. Sometimes piecewise functions connect, sometimes they do not. This one does not connect. No big deal. You just do kind of follow along the whole function notation here. Moving on, now we have a weird one. This one has 4 functions, 1, 2, 3, 4. Well, where's the x? Well, there is no x. This is like y equals 1. Y equals 1? What the heck does that look like? Well, this is y equals 1, this whole line. However, I'm not graphing y equals 1. I'm graphing only y equals 1 from -4 to -3. The x has to be between these two. -1, -2, -3. Here's -4. Here's -3. I'm only graphing this segment. So I'm going to erase this. Now you don't have to draw and erase. You can just draw the part that's important if you can get it. Now that's all it is one little piece here. Y equals 1 when the x values are this. This is an equal to, this is not. Close circle, open. I'm going to do one more. Y equals 2. From -3 to -2. -3 to -2. Okay, y equals 2. Here to here. Feel free to pause the video and do these last 2. Ends up looking like this. This function is special. It has a special name. It's called the step function because it looks like little stairs. Okay, so this one doesn't go off forever because I'm only limited between these two numbers. Whereas on the last one, it does go on forever because everything bigger than 2 goes this way, everything smaller than 2 goes this way. All right, now that was kind of the easy part, or supposed to be the easy part. Now comes the creating the equation. Write equations for the piecewise function. Oh, okay. So an equation is f of x or y. Either way, I like f of x equals. Now you get to draw that beautiful curly bracket. I love that. Whoops. Let me go back. I'm going to start with this one with the closed dot here. I wonder what its slope is. Down 1 over 1. Down 1 over 1. Down 1 is negative. -1x. That's a slope. I wonder what its y-intercept is. Ooh, it doesn't intersect the y line. But if you kept going, it would be right there. Okay? You don't have to keep going, but if you did, it would be right there. So that would be a y-intercept of 1, 2, plus 2. Now, This piece, I only want to graph when x is less than, because it's going to the left, less than what? Less than -1. If x is less than -1. Should it be less than or equal to? What do you think? Filled in dot. Equal to. Well, let's do the other one. Y-intercept's a tricky one for this one. Y-intercept. Whoa, what happened there? Y-intercept. Ooh, the y-intercept looks like it's -1/2. Now I need the slope. Down 1 over 2. I'll draw that in there. Down 1 over 2. Down 1 over 2. That's the slope, so it's in front of x. Y equals mx plus b. Now, if x is bigger than, not equal to, because of the open circle, -1. How did I know it's -1? Well, look at the starting value. -1 is the x. Look at this starting value. -1 is the x. The x conditionals, that's called a domain, the x's, that's what you need for these functions. All right, looking good. What about a story problem? Okay, well, story problem's not that bad either. So let's kind of take a look at this. Shipping costs $6 on purchases up to $50. So if you bought something under $50, like a $25 watch or something, and you got it shipped to your house, it would cost you $6. Now, they jack it up to $8 if your purchase was between $50 and $100, and $10 on purchases from $100 to $200. Write a piecewise function. Well, that should be pretty easy. Piecewise function is the y equals or f of x equals. I'll use the y this time. Now, this $6 is a flat fee. It's not going up at a certain amount. So it's going to be just good old y equals 6. Up to $50. Now, f would be like how much you spent on it. How do I do up to 50? Could I spend $-? I don't think so. So I know that the x has to be between 0 and 50. Looks like this. X is between 0 and 50, kind of like that step function from before. Would one of these be an equal sign? I'm not going to put an equal to on 0 because you wouldn't have anything shipped to your house if it was free. I mean, I guess you could. I guess you could get something for free. So I guess that's kind of arbitrary. It could go either way. $50 up to, so it was including 50. That kind of implies including 50. And then it goes up to 8 if 50 to 100. Same idea. 50 less than x less than 100. Where does the equal to? Can't be on both these. It's got to be on one or the other. So this is over 50, but up to and including 100. And if you want to try the last one, go nuts, but it's pretty easy. $10 if 100 less than x less than or equal to 200. There you are, ladies and gentlemen. Piecewise functions, an application in the real world using shipping costs. We'll talk about other applications in class later, but this just gives you an overview on how to do piecewise functions. This is your assignment for lesson 2.7, page 117, 14 to 28. These are all evens, so because I said even after all this. 14, 28 even, 36, 38, 42 to 46. All of these are evens. And then 58 and 59 for some stories. Good luck. I hope you do well. You can always, if you need more help, ask in class or listen to some of the other stuff on iTunes U.